So these are getting into what I call the trickier trinomials. The 4 questions on this page are different from the questions on the previous slide in one major way. The coefficient for x squared, in this case, for all 4 questions, is no longer 1. So the strategy has to be a little bit different. For example, in the case where we had x squared plus 5x plus 6, here the coefficient of the x squared is 1. We were looking for 2 numbers that when I multiply them give me the last term, the 6, but when I add them give me the middle term, the 5. And that was 2 and 3. So we went ahead and used the 2 and the 3 in the second position. For each of these, there's no such combination. There are no 2 numbers that multiplied to give 2, but had to give 5. So that can't be the whole story. In the case of x squared plus 5x plus 6, we know we had to have an x in each position as well, because those first 2, x times x, gives me the x squared. That's where we see some of the problems start to come in, because here I don't have an x squared, I have a 3x squared. So I already know that rather than having x and x, we have to have 3x and x, 3x and 1x. 3 and 1 are the only way to get to 3. 3 is prime, so that makes these problems not too challenging. Similarly, I don't have a lot of options for the second, so the same way that the 2 and the 3 multiplied to give 6, how do I get to the 2? Well, I have to multiply by 2, or multiply 2 times 1. So the only thing I'm not sure of is, should I be writing the 2 in the same bracket as the 3x and the 1 with the x, or should they go the other way around? In other words, if I have a second option, I'll write 3x and x again. Should the 1 go in with the 3x and the 2 in with the x? Well, let's try them. One thing I do know in both cases, because I'm trying to multiply to get a positive 2 and add to get a positive 5, is that all of my values will be positive. And another thing you'll notice on this slide is that I always have a positive coefficient for the x squared. It's much easier to deal with a positive coefficient. And I'll show you what to do when we have a negative coefficient on a later slide. Okay, how do I know which one's right? Well, I know how the first and the last work. I know that 3x times x is 3x squared in both cases. I set it up that way. And I know that 2 times 1 is 2. We chose those numbers, so we don't have to do an extra check of them. What we do have to check is to say but 2 times x, x. So that means I have 3x squared plus 3x plus 2x, a bit of a lag here, plus 2. And I was sure about the 3x squared and the 2. I'm not really worried about those, but I want to check whether the middle terms, the like terms, will give me the 5x. And 3 plus 2 is indeed 5. So it turns out that the first way I happened to write it did give us the correct answer. What does the other one look like? Well, if I have 3x times 2, the outside I get 6x, and the inside 2 give me 1x. So instead of having 3x plus 2x in the middle, I have 1x and 6x, which gives me 7x, not the 5 that I want. So I know that the final answer here is this first one, 3x plus 2 times x plus 1. Give ourselves a little bit more room here and tackle the second one. This one's very similar. It has all positive terms. Set it up the same way. It is a quadratic trinomial, x squared, x, no x. So we know I'll have 2 binomials multiplied together to give me the answer. Again, the first and the last are prime. So this is best case scenario really for a trinomial that doesn't have a coefficient of 1 for the x squared, because I know that I can only use 2x and x to get to 2x squared. So I'm going to write that down twice because we're going to have 2 options for the final answer. We only have 2 options because there's only one way to get to 5. I have to multiply 5 times 1. It's prime as well. So I'm not sure if the 5 goes with the 2x or if the 1 goes with the 2x. So I'll write down both and check them. You can certainly just write down 1 and check it, and if it happens to be right, you're done. If not, you'll have to try the other variation. All right, so outside is 2x, inside is 5x. 5x plus 2x is 7x. That's not 11x, so this is not the correct solution. In the second case, we have 2x times 5, so that's 10x, and 1 times x, which is just x, which is 11x. That is the middle term we're looking for. How did I know what the signs were when I came up with these? Well, I should have written them in ahead of time because I could. They are all going to be positive because all terms in the question are positive. So I know that that's our solution. If you're still not convinced, absolutely FOIL out the entire thing, not just the outside and the inside, and you will get the 3 terms in the question. Again, try these next 2. They're similar. Coefficient of x squared isn't 1, it's a 7 here. The middle term is negative and the last term is positive. I'm going to write out some options. It must have a 5x and an x. First and last are prime again, so not too many different ways to write it. So the only 2 options are 3 and 1 in this way, and 1 and 3. So this time I'm trying to multiply to get to positive 3, so I either need positive 3 times positive 1, or negative 3 times negative 1. And because my middle term is negative, the negative 8x, these are both going to have to be negative. So of course the other option is if this final term is negative, I know that one of the 2 has to be negative and the other positive. Let's see where we're at. Checking the first one. 5x times negative 1 is negative 5x, and negative 3 times x is negative 3x. I don't even have to check the next one. Negative 3x plus negative 5x is negative 8x, so that's the correct solution. Some questions will light upon the answer right away. More than any other problem, there's some guess and check. There's an element of a leap of faith in all of the factoring problems. But we're so much more comfortable to do the checking, to do the binomial multiplication, that's not so bad. All right, 7x, and I wrote 1x, but really we just need to write x. And then I'm either going to have 5 and 1 or 1 and 5, and I'll finish filling in the values. Are these positive or negative? Well, they have to multiply to give positive, but add to give negative, so it must be negative 5 and negative 1. Which one should we check first? Which one looks more likely to be right? I'm going to try that top one. So 7x times negative 1 is negative 7x, where negative 5 times x is negative 5x. Add those 2 together and I get negative 12x. And once again, the first one that we check is correct. So I don't have to check the second one, but I'll show you what we would have gotten. The outside is 7 times negative 5, so that's negative 35x. And the inside gives me negative x. There's definitely no chance here. Very clear that this cannot be the final solution. All right, we're going to up the ante just a little bit here. Let's have a look at all 3 problems. Same instructions are given, factor completely. So we're not told any more information off the bat. We have to have a look at questions and see what the likely answers will be. There are quadratic trinomials, x squared, x, constant, and they're already in order. The x squared term is first in all 3 cases. In the first 2, I've got positive coefficient for the x, and the last one I don't, so we'll tackle this one last. So that's going to look a little bit different. What's different from the previous was that the first and the last term aren't both prime. It just means I have more options. It means I have more options that I'll have to check. Okay, let's start looking at our possibilities. I'll just draw one of them. I know it's binomial times binomial. What do I want in this first spot? I want x times x. Either 4x times 1x, or I could also use 2x times 2x. So now we have more options than we previously had when the first term was prime. But for the second position, that one's still a little bit more straightforward because only 3 and 1 will give me 3. So let's start looking at the possibilities here. So if I have 4x times 1x, it's possible that the 3 belongs with the 4x and the 1 belongs with the x, or of course the opposite. Perhaps I have 4x and 1 in the same bracket and x and 3 in the same bracket. And then I have a third possibility where I've got 2x times 2x to give me the 4x squared. And then it doesn't matter if the 3 or the 1 goes in the first bracket. Even if I flip those around, I haven't actually created a new option. But this time I'm not going to go ahead and put in the negative and positive signs because I'm not sure where they belong. In order to get to negative 3, I'm either going to have to use negative 3 times positive 1 or negative 1 times positive 3. I do notice that for the middle term, when I add my outside on my inside, I'll have to end up with a positive value. So I'll keep that in mind. So let's start looking at the possibilities. We know that the first and the last work. We just chose those, so we're going to focus on the outside and the inside. 4x times x is 4x. 3 times x is 3x. 3x and 4x, even if one of them is positive and the other one negative, adding those together will never give me positive 4x, so there's no solution to be found in that combination. Similarly here, I've got 12x and x, so even playing with the sign of the 3 and the 1, there's no combination that will lead me to positive 4. And maybe you got lucky and this is actually the option you wrote out first, in which case, well, it's the only remaining option, so this must be the right one, but let's see why. We don't yet know what the signs are. 2x times 1 is 2x, and 3 times 2x is 6x. Now remembering that 1 has to be positive and 1 has to be negative, if I make the negative 2x, if I make the 2x negative, 6x minus 2x, yeah, that gives me 4x, so we're well on our way. So what do the signs have to be if that's the case? Well, I know I need 6x to be positive, and I have got a positive 2x, so the 3 must be positive. And I'd like the negative 2x to exist as a negative value, and I have positive 2x so far, so I have to put a negative in front of that one. So there you go. Try the next one. Now you can spend quite a bit of time trying to sort out this last one. But I'm going to remind you that it asks us to factor completely, which means that if there is a common factor, at some point you will have to remove it. And it's much easier to factor these problems if you remove the common factor right off the bat. 25, 45, and 10. Those have a common factor of 5. So let's go ahead and pull that out. So I'm going to divide the trinomial by 5. 25x squared divided by 5 is 5x squared. 45x divided by 5 is 9x. And negative 10 divided by 5 is negative 2. Hey, that's not so bad because now I have a perfect, or I have a slightly easier trinomial. It's going to say perfect square. It's not a perfect square, but I have primes front and back, so I really don't have that many options. So I definitely have to leave that common factor out front, but I know I'm limited in my options for the inside. Let's sneak these in a little bit. Right, so I can only use 5x and 1x to get to 5x squared, and I can only use 2 and 1, and I'm going to guess that they're this way around, to get to the 9x. Again, I know that either the 1 or the 2 will have to be negative, and maybe I throw these in ahead of time and check afterwards. So a guess and check approach here. Now remember, we know that the 5 is on the outside. I'm just going to leave that there. I'm just worried about having the 5x minus 1 and the x plus 2 become 5x squared plus 9x minus 2. All right, so the outside there is positive 10x, and the inside is negative x. I just assigned these randomly, but I'm happy to find that positive 10x and negative x do give me that positive 9x. So I've landed on the correct answer. If I'd switched the negative signs and ended up with a positive x and a negative 10x, which gives me negative 9x, no big deal, just flip your two signs. Sometimes we'll have an awfully long list of options to try, and sometimes we land on it at the first attempt. For the third one here, what do you see? Well, it's related to the second one in that I've got a greatest common factor of 3. 6, 33, and 18 are all divisible by 3. So while those numbers look big, I can shrink them down a little bit by taking out the common factor first. The other thing I don't like about this problem is the negative x squared. So I'm going to pull out the negative. If you go back to common factoring, I did discuss this briefly, that sure, you can pull out a negative, and we did it in one problem, but this is where it's really useful. So not only does it look a little bit ugly if I have a negative first term, but it's harder to factor. So I'm going to divide out negative 1 from each of the 3 terms. Negative 6x squared divided by negative 1 is positive 6x squared. 33x divided by negative 1 is negative 33x. And similarly, we get negative 18. Try it forwards. Negative times 6, negative 6. Negative times negative is positive. Negative times negative is positive. So we're right. So we're just going to now focus on factoring positive 6x squared minus 33x minus 18. Now I did say we had another common factor, and that's the 3. I could have taken it out at the same time. So you can do what I'm doing in 2 steps in a single step. Not too bad. And we end up with 1 prime number, and a 6 doesn't have too many options. We can only use 2 and 1 to get to 2, and 6 could be 6 times 1 or 3 times 2. So we won't have too many options that we have to check. Let's write out the format here. So I know I'm going to have 2x and x. The question is just if I use the 6 and the 1 or the 3 and the 2. So maybe before I start writing down the guesses, I know that those outside 2 and those inside 2, those I'm somehow going to have to use to end up with an 11, a positive 11. So here again, I could have 6 and 1, 3 and 2. What looks likely here? One other thing that I notice here is that I'm going to have, I rewrote these as positive 11 and positive 6. Definitely an error there. There's no reason for me to have changed the signs again. And for what I was about to say, I was going to say that I noticed that I have to multiply 2 values to get to negative 6. So one will have to be positive and one will have to be negative. Now it all works out. Okay. So the 2 values here, the 6 and the 1, the 3 and the 2, one will be positive, one will be negative. If I had 2 and 6, that's pretty big. That would get me to 12x. And that means I'd have to put a 1 here. 1 times x is 1x. 1 and 12, if I make one of those negative, that'll absolutely give me the negative 11x. So I want the 12 to be the negative 1. I have a positive 2x, so it's the 6 that I'll make negative, and the 1 will be positive. Okay, so let me tidy that up a little bit. The answer there is negative 3 times 2x plus 1 times x minus 6. If you didn't get to it on your first crack, you just keep trying to substitute in different factors. I will show you some other techniques when the numbers start to get a bit bigger. because when the numbers get bigger, the options that we have here get bigger as well. I tend to do it, this factoring I will always do this way, writing down the factors for the first and the last term. But there's some other tricks, and I have some nice videos for those as well that I've pulled from Khan Academy, Nancy Pye, and Patrick JMT.